Okay, so this is your guided practice for today. What I would suggest you do is pause this video and attempt to do these 6 questions that are below. And then, of course, unpause me once you've done maybe each part, and I will work them out. So in part A, we have the integral from 0 to 2 of f of x dx. So what that means is find the area between the x-axis and the curve of f of x on that particular interval. So on part A, we're going from 0 to 2. So what we'll be doing is finding this area right here. I'll shade it in. So as you can see, that is, well, part of a semicircle. It's 1/4 of a full circle. So we all know what the area of a circle is. The area of a circle formula is pi r squared. Well, we only have 1/4 of a circle, so we're going to say the area of our circle is 1/4 pi r squared. Well, our radius, of course, is going to be 2. We're going from the center of the circle right here to here. That would be the radius of 2. So the area of our circle is going to be 1/4 of pi times 2 squared. Well, 2 squared is 4. 4 times 1/4 is 1. So this is just going to give you pi for our answer. The area of our circular part is going to be pi. So I'm going to put that in here. This is pi units. That's what this would be equal to. However, since the area is below the x-axis, this will be a negative value. So it is negative pi. All right, next, part B. The integral from 2 to 6 of f of x dx. Well, this, of course, is just a triangle. So what we're going to do is find the area of the triangle that is from 2 to 6. Well, the height of this triangle is 2 units. The base length of our triangle is 4 units. And the area of a triangle is equal to 1/2 base times height. Well, the good news here is we know both of those. We know the base is 4. And we know the height is 2. So therefore, the area of our triangle is 1/2 of 4, which is 2, and 2 times 2 gives us 4 for an answer. So this will be 4 units. Okay, part C. The integral from -4 to +2 of f of x dx. Well, we already know that the area of that red region that I found is pi. That means that this area is also pi, and then we need to find the area of this region right here, which is a triangle. Well, this is 1 unit. That's the height of the triangle. The base length is 2. And again, the area formula for a triangle is 1/2 base times height. So 1/2 of 2 times 1. Well, of course, that's just 1, but since it is below the x-axis again, we need to understand that that's a negative value. So this is like a -1 area right here. This is like a negative pi area. This is a negative pi area. So what we end up having here is we need to add the individual areas together, and that will give us the integral from -4 to +2. So we will have -1 minus pi minus pi. Since there are 3 different regions, we will simplify this to be -1 minus 2 pi, and that would be your answer to part C. Let's see if I can get the box to come around this one. There we go. All right, next. The integral from -4 to +6 of f of x dx. Well, again, all we're going to do, find all the areas and add them together. We already know what the area is right here from -4 to +2. So we just need to add in this area right here. This one. So we know that that area is 4. So we're going to take -1 minus 2 pi. That was our answer from -4 to 2. And add it to 4. Now you can simplify this. This will be +3 minus 2 pi. And that's your answer. So in part E, the integral from -4 to +6 of the absolute value of f of x dx. Well, what we will do is anything that is below the x-axis will get reflected across the x-axis to be positive, because absolute values will make our negative y values positive y values. So I'm going to graph that in green here. So right here, this coordinate, -4, -1, will become -4, +1, because the 1 will become a positive value when you absolute value it. That means this coordinate will be here, and we will have a line that looks like this. Okay, so this circular part is also going to get reflected, so I'm going to see if I can sketch that to make it look correct. We'll see how good I do here. Okay, so this area right here, this area, this triangle, and then this area that's above the x-axis, and then, of course, this area, which is above the x-axis, will be the integral from -4 to +6. So this area right here, which was a negative value, is going to be a +1 now. This area was -2 pi, but now it's +2 pi. And then, of course, this area was already positive, so it remains the same. You don't do anything with it. This area, of course, is 4. So we're going to add all of those values together, 1 plus 2 pi plus 4. That gives us 5 plus 2 pi. Sometimes you can write that as 2 pi minus 5. It's the same thing. All right, the last question here says the integral from -4 to +6 of f of x plus 2. Don't have a lot of room right here, so I'm going to write it up here. So hopefully you remember that there's a rule that involves integrals where you can separate integrals when you're adding or subtracting parts. So in other words, we can do this from -4 to +6 of f of x. Again, that's this part of this one. Plus, I need to put a dx there. Plus the integral from -4 to 6 of 2 dx. Okay, here's the good news. We already know what the answer to this part of this is. We've already done it on a previous question. We did it right here. So we know the answer to that, so the only thing we really need to figure out is the answer to the second part here, this. Okay, so we've talked about how to find the integral of 2 before. You simply raise the power of x, so that would be 2x evaluated from -4 to 6. All right, so then we have to do the fundamental theorem of calculus with this right here. So we're going to plug in 6, and then we're going to plug in the -4. So we'll plug in 6. That's going to give us 12. We always subtract. You're going to plug in -4. That's going to be a -8. Well, 12 minus a -8 is +20. So +20. We're going to add that to our answer from part D, which was 3 minus 2 pi. So all we will do is add those together. That's going to be 23 minus 2 pi. Now, one of the reasons that this is the case, I just want you to think about this. We went from -4 to +6. That's 10 units long. If you take 10 units long and multiply it by 2, this right here, because you're adding 2. So you're thinking about 10 units long times 2. It's like a rectangle. So that area is 20. So it makes sense that this answer right here that we got was 20, that we're adding it on to our answer from part D. So, all right, I will continue to give you a couple more of these. That is the first one.